The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.
Hello and welcome back to the Ben Heck Show. In today's episode, we're going to finish building the Raspberry Pi MAME portable. Here are the steps. First, we're going to stuff the PCB that Felix etched in the previous episode. Then we're going to finish the case design. Once we have the PCB in hand, we can see if there's anything we missed and make the case correct. Then we'll wire and test the PCB to make sure it works in its final configuration with the Raspberry Pi, the control PCB, and the screen all sandwiched together. While we're doing that, we'll 3D print the parts in order to make the case, and then finally we'll assemble it all together along with the battery pack to make a completed unit. Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
It's time to stuff the PCB that Felix designed in the previous episode. We also had a test PCB that was built to make sure the circuit worked, so I'll be using this for reference along with the Eagle file that Felix designed. Time for me to get to work. Placing surface mount components isn't as difficult as some people think. However, we don't have solder mask, aka the green stuff, on this PCB. Solder mask does just that. It masks the solder and prevents it from going places you don't want it to go, namely the traces. When we place our components, we have to make sure that they're centered on the pads correctly and not sliding onto traces, because that would be bad. I'm going to place them all in order, going counterclockwise around the board, referencing our Eagle design as we go. For integrated circuits, I pin down the two corners of the circuit to keep it in place, and then I flow solder on the rest of the pins to make them stay put. I do the same for the power MOSFET, and I'm also adding a little bit more solder than we need to help with the heatsink. Then I check my Eagle schematics to make sure everything is correct. Next, I add the through-hole components such as the switches and the power connector. Now I'm going to add some wires that act as the bridges or jumps between connections. This is a single-sided board, so the things that would normally be connected on the back of the board, we're having to connect on the front using bridge wires. We probably should have ordered some double-sided boards through a service. However, that would take a few weeks, so to get this project done, we're just going to wire that manually. Of course, for mass production, you would be insane to do this. I'm making sure all the wires that I add are flat and stay lower than the top surface of the buttons. This way, they will not interfere with the controls. They might look messy, but they will be out of the way. Now the PCB has been stuffed and it's ready to go. Let's take a look at it. Here's the charging circuit. This will charge 2 lithium-ion cells. Here's a directional pad for moving your character, 4 tact switches for menu, 4 action buttons here, indicator LEDs for charging, and this is your power input jack. So now we need to think about how these pieces are going to connect together. We have these headers here, and I believe they're going to do the trick. Let me show you the basic idea. The headers attach onto the bottom of our custom PCB. We will then attach the screen to the top of those headers here, using the through-hole pins to make the connection. Then this screen can be plugged into the Raspberry Pi, and these will be the two halves of the unit, the screen and the controls on one half, and the Raspberry Pi itself in the rear. Let's manually solder it together. We have a through-hole header going through the PCB that we made. The top of those connections poke through the vias on the screen. By flowing them with solder, we are able to attach the screen to our PCB and finally down to the Raspberry Pi. The screen and the control PCB will be soldered together as one unit. Now I am adding the digital connections for the buttons and controls. We can use thin wire since it will not be carrying any amount of current. It will just be a signal. You have to be careful with the thin wire as it is solid strand and could break if you move it too much. I put it in position and then I make 90-degree bends using my tweezers. This keeps the wires straight and makes them easy to organize. It's kind of like sewing, except for with electronics, so it's way cooler. We started designing the case in the previous episode. Now we're going to finish the design and turn it into a 3D model. This is the basic 2D design we started with. It has the Raspberry Pi, battery, the screen, the PCB with the controls, that's all drawn up. And then we also have a elevation or thickness view of it. And as you can see, the batteries are gonna poke out the back of the case a little bit. So we turn that into a Autodesk 123D file, and this is basically the same as the AI file. I actually redraw it in here. I don't import it because that's safer. Takes longer, but it's safer. So this has all the features, and we also have the standoff screws for the PCB. And at the top here, we have a few things for the headphone jack and the HDMI. So I will just turn on the 3D layer here. Okay, now you can see. There we go. So the PCB will sit in there. The screen has its opening. And then we have some concavities for the charge jack. Over here we have the USB. Up at the top we have the audio and the HDMI. There's also a little bit of a lip here along the edges, which will help the pieces of the case fit together well. Let's take a look at the back of the case. For the back, we did the same thing. We started with a 2D drawing, then we extruded it up to create the thickness. We have an easy access USB port here, basically a big chunk out of the back of it, and then we've enclosed it so it looks nice. The top, we have our headphone jack and a full-size HDMI cable. There's a big hole here, that's where the batteries go. We need to make a little bit more space in the back for the batteries to fit, so the last thing we'll print is a little cover back here that'll give us a little bit more depth and allow us to keep most of the unit as thin as possible. We also have a spot here for the charge jack and over here for the power switch. And the screws in the back are countersunk as well. Let's start printing. Felix did a test earlier where he used acetone to smooth out the surface of the ABS print. I think it's a pretty cool effect, so I'm going to use it on this final print. See, we actually did this a couple times because we changed a few things. I'm going to put some acetone on it and try to improve its looks. We actually sanded this one nicely too, unlike that one. Let's see what happens. I'm just going to gush it on there. Yeah. Yeah. Oh yeah, man. It's a party in here. Whoa. Yeah, for some reason one day I wanted to see just how flammable this stuff was. And it's very flammable. Many flammable. Acetone also helps to seal the print and strengthen it, especially between the layers. Basically, it's a solvent for ABS, which also makes it act as a glue. But you don't have to take my word for it. I'm going to let this evaporate and see what kind of smooth, shiny surface we get. Say that 3 times fast. Smooth, shiny surface. The front piece turned out pretty nice and smooth, so I'm going to do that to the other pieces. The back of the unit needs a little bit more room for the battery to fit, so I've made this extender piece. So I'm going to just acetone this all at once, and the acetone will act as glue to make these two pieces stick together. Enough talk, more action. Now it's time for a tech timeout. In a previous episode, we did a tutorial on how to make a single-cell lithium-ion battery charger. That was all well and good, but sometimes you want multiple cells for more power. So that's what we did for this current Raspberry Pi project. We have the LTC 4006 lithium-ion battery charger. The thing that's great about it is it can select how it powers your load. The load is the Raspberry Pi and the LCD. And that goes through a 5-volt power regulator that takes the voltage from the wall wart or the battery and drops it down to a level it can use. So the LTC can take the 12-volt wall wart, use the current sense resistor to tell how much it's charged, the lithium-ion batteries, and it controls the charge using a few MOSFETs. So it worked out pretty well. It's a smart battery charger that we're able to integrate into the unit instead of having it be an external charger like the previous Pi MAME portable. Let's work on the buttons for this project. These lines represent the holes that we made in the case. So we're going to come in about a 32nd of an inch and make our buttons there, and then we need flanges to hold the buttons in place. Let's look at this at an angle. We're going to select the buttons themselves, the parts that actually sticks through the case, and those are 0.243 inches. Then the flange, we need the original button size plus a little bit extra to hold the button inside the case. We will make those 0.05 inches. The design shows a 1/16 of an inch, so I'm going to go a little bit under that to give it some slop. And then this piece, which basically holds them together, I'll just make that very thin. Oh, there's our button structure, and these will print all in one piece. I'm going to grab this tool and I will fill up the edges to make them round or something. Yeah, just a little bit. That's good. All right, we can print those all in one piece. I'm going to do the same thing for the 4 action buttons, but I'm going to print them separately so they can have different colors, like a Super Nintendo, which actually isn't entirely accurate because Super Nintendo just had 2 shades of gray, not 50. What? Neo Geo, I think, had multicolored buttons? I don't know. So we'll print these in black, and then we'll print the action buttons in multiple colors. Then we'll also make a cool directional pad that goes right here. I have the buttons, and they fit inside the case. Now I can finish up the unit and install it. The main parts are battery, indicator light, 5-volt regulator, and the PCB that we made. Here you can see that it comes apart into pieces, so we can actually unhook this. The Raspberry Pi itself will be in the rear of the unit, just like this. This will be in the front. The battery will connect between the 2 sides, and then when we sandwich it together, the headers will meet up, completing the circuit. Time to start wiring. Hey Allison, do you know how to do the sloth still? What about the Space Jam? Apparently when Allison was a kid, she came up with this whole dance for Space Jam, but it's like a secret she'll never show. There's a Raspberry Pi bolted in place. You can get at the headphone jack and the HDMI and the USB. Evil Dead quote. Here's your new home. I want to make sure I can hear the buttons click. Make sure there's enough spacing for everything. Okay, they all sound good. I can proceed. Before I can install this in the front, I need to move the regulator to the back and make sure it's not going to hit the battery. Where the regulator was going to go has changed a few times, so I have to find its new home. And I have no idea where that's going to be. So that's where we're at right now. I'm making the final connections to finish this project. We have our battery here, and we're going to attach the wires to the other side here, and they're going to attach around this joystick. So we have to make sure we lay them flat so they don't get in the way of anything. So this is the charging circuit that charges the battery, and then that charging circuit goes into our 5-volt regulator, which will actually send the voltage to the screen and the Raspberry Pi. And we have just enough room to make everything fit, so yeah, it's gonna work hopefully. So I'm gonna start wiring it up. Again, I'm doing the wires in such a way that it can fold together like a book, so it will have the best chance of fitting when we close up the case. I've said this a lot, but I'll keep saying it. Wires take up a lot of space in a project, so don't forget about them, or don't forget about how much space they take up, because it's a lot. It's easy to forget about the wires, but you shouldn't. Okay, so this battery is live, so I want to make sure I don't short anything out, because That would be bad. So hopefully no Midwest earthquakes occur right now, or ever. I'm gonna snake those around the D-pad there. Make sure they're well connected. They appear to be. I'm gonna add just a little bit more solder to this. And in my head, I'm picturing what would happen if I shorted those out. Okay. Now to close this up, we need to add the D-pad, which is more of a disc, really. The D-disc. Come on, get on there, D-disc. There we go. Now I'm going to secure it to the front half of the case. And if everything was designed correctly, these headers should line up and complete the circuit, allowing it to run. Checking all directions. Always be clicking, ABC. It looks so much simpler than it was to build. I guess that's the point. Before we close it up, let's take a final look at the parts. Battery, Raspberry Pi A+, power switch, 5-volt regulator, custom board with charging circuit and controls, header that connects the screen and the Pi and the controls all together, and the Adafruit TFT screen. All right, let's close it up and see if everything fits. I'm gonna plug in an external speaker and play some arcade games. Yeah. This was back when every game had to have ninjas in it. So imagine now, but instead of zombies, ninjas. For this project, our challenge was to make an improved version of the Pi MAME portable that we built back in 2012. We wanted to make it more kit-like, use a better screen, and integrate the battery charger internally. We started by setting up the SD card with a Cupcake OS in order to easily use MAME. The OS was then tested on both the Raspberry Pi B+ and A+ to make sure the TFT display worked with all system types. Next, we compiled a program that sets the general purpose input-output lines to act like keyboard presses, which would give us our game controls. Felix then designed a PCB that included both the game controls and the battery charging circuit. Finally, we made a 3D printed case and stuffed all the components inside. I feel this project met the challenge of improving our existing design, plus Felix battery charging circuit will be super useful for future projects. I'm not entirely happy with the case we built. The acetone smoothed the surfaces, but it also caused some warping, making it more difficult to put together. We could have made this using the laser, but then again, we wanted it to be kit-friendly and use as few parts as possible. Things I would have done differently? Well, we should have ordered a professionally made PCB instead of making our own single-sided board. The single-sided board worked, but required a lot of hand bridging to make the circuit complete, which took away from the simplicity of the project overall. How would you have approached this project? What would you have done differently? Go to element14.com and share your thoughts with the community. That's all the time we have for today. In our next episode, we'll take a stroll down memory lane. That's right, we're building a time machine. Or at least, we'll share what we've learned from a project that didn't go quite as planned. We'll see you then. So let's look at this. So let's look at this at an angle. When I get hungry for innovation, I go to Culver's, home of the Butter Burger. 3, 2, 1, lift off. It's a horrible rocket sound. 3, 2, 1, let's go. Shania Twain. Is this the first thing we see in the second episode? Oh, am I supposed to say that to the camera and act excited? This is riveting. Except for these are screws. So again, I always say that. So again, as you can see. So again, as you can see, it's on the up and up like McFarland. Oh yeah, you know, they got the quick trip there with the amazing lunch. You can write this stuff, George, but you can't say it.
The Ben Heck Show is brought to you by Element 14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at element14.com.